Hey, hey,
We're back.
there's Kurt. Kurt. Hey,
Hey,
hey, hey. My face there.
Hi, Karen. Hey,
Hey,
that okay?
good, good. Good evening, everybody, and welcome back to our Sunday night offering of Astronomy Edutainment, the Sunday night astronomy show.
hey.
Yeah.
Always the same with Kurt on. My name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. Hey, no, I'm also an amateur astronomer and a member of the Royal Astronomical Society of Canada.
Yes.
Hey, leave it at that. I'd like to welcome back my two regular co-hosts this evening, Mr. Paul Owens from the Moon Shadow Observatory in beautiful Hampton. Paul, good evening, sir.
Good evening, each and every one of you.
And Mr. Mike Powell from the PFO Observatory here in St. John. Mike.
Today.
And we'd like to welcome all of you from YouTube and Facebook land tonight. Thank you so much for your support. Now, on tonight's episode of the Sunday Night Astronomy Show, now humans have only ventured about 400,000 kilometers or 3 days travel by spacecraft from the Earth. A one-way trip to Mars using current technology generally takes between 7 and 8 and 10 months. Now, that's a lot of time in space. If it's truly our destiny to travel to other worlds, we need to understand exactly what happens to the human body in space and understand if we can overcome any obstacles for long duration spaceflight. So, tonight's guest then, RASC member Kurt Nason, will help us understand what we have learned so far and how the effects of space will determine whether we can indeed become space travelers someday. Welcome back to the show, Kurt.
Thank
Hey.
you, and happy Mother's Day.
Yes,
Yes, that's right.
happy Mother's Day for everybody out there.
I forgot.
Yeah. Oh.
No, I didn't.
Also tonight, Bino Bud's going to return with another fine binocular target of the week. Paul will be delivering another interesting Rosanna's fun fact. I'll have a quick look at some celestial events coming up, along with the display of your photo submissions. Now, before I go any farther, we were just talking before we get on air here about our program and how we've kind of settled into this routine of how the show runs. So I'm going to ask you folks if you have any ideas for us to spruce up the show a little bit.
We have to spice up our marriage.
Spice up our marriage. That's right. So we're going to go back probably to a little bit of a change in format, maybe little segments again, like we used to do a while back, but we're discussing it amongst ourselves, but we'd like to have your input too, because of course we want you to come back to the program as well. So if you have any ideas for the program, talks that you'd like us to cover or whatever, give us a little comment here while I'm watching both YouTube and Facebook.
There we go.
Okay, so
You
let's
sure you
start.
want your input?
Hmm?
You sure you want your input?
Oh, sure. Well, I'll take the input. I'll just see what happens. So let's get started then with tonight's program and a chat about the human body and how it reacts to space. Mr. Kurt Nason, tell us how that
Okay.
happens.
Well, I've never written on the ways of space, but I have surfed the internet. I had to come up with this for a school talk here a few weeks ago.
Okay. Now, some of those who were at our local St. John Astronomy Club meeting might have seen this already, but tune in anyway. So still render.
Okay. First of all, is there gravity in space? Yes, there is. So pretend you're at a 5 kilometer high elevator and you step into it, have the door closed, and all of a sudden the cable snaps. You're going down very quickly. But you might notice you're not very steady in there. You might be floating a bit, it seems, and you want to call your mother, so you take your phone out and you're fumbling with it and you drop it, but it doesn't fall either. It's staying right there in space with you as you're falling down. So you're in free fall. So you're going at the same rate as your elevator's going and your phone's doing the same thing. So you're more or less floating in there like they do in the space station, as you can see in here. So there is gravity, and gravity is trying to pull the space station down. As they say, space station wants to crash, but it keeps missing the Earth. Space station is going, well, it's roughly to 360 to 400 kilometers high, going approximately 25,000 kilometers an hour. So at the altitude it is, it's going fast enough, so it's just going to always stay in that particular altitude, like that. So if you drop down a bit, the gravitational force is going to be a little bit greater because you're closer to the center of the Earth and you're speeding up, maintaining that speed so you're staying in orbit. You go up a little higher, you slow down, you're at that right speed to stay in orbit all the time. Right, so there is gravity. So when you hear somebody say zero gravity, it's not a correct term. I have to use microgravity a lot now, or free fall. Get that out of the way. So what your body's going to notice first is when you're having the blast off. So one G force is at 9.8 meters per second squared, the force of gravity pulling you down. And if you're coming up against that force, you're going to have to go a lot faster than that to counteract it. So typically in the blast offs here, they're going several G forces, several times the force of gravity to get up and escape to get up to a free fall. And for us, normal people, you got to maybe a few G forces going up. The blood would be rushing down somewhat from our head and our eyes. And we can have some temporary loss of vision from that. And for us, maybe at 3 or 4 G forces, a little bit higher, we could pass out. Now, for astronauts who go up, they have G-force training. You've probably seen the centrifugal whirligigs around there that'll go around very fast and give them an extra G-force to get used to that. And also the G-suits that they wear tends to keep the blood in the head. And they try to keep the blast off, the speed going up, but something that's comfortable anyway. So that's your first bit of discomfort. And once you finally get in orbit, one thing you're probably going to do is fluff your cookies, maybe in the first few hours, because you're not used to being in free fall like that. You can see what happens there. You get your hair going all funny like that if you have lots of hair. So I think it's about 45% of the astronauts that have gone up have vomited, like when they went up. And you experience other discomforts, dizziness, headaches, lethargy. You don't feel like doing anything. Everything's so different for you. You're really disoriented. So it's going to take a little while to get used to that. So you learn to fly through the space station. Right, one thing, you're going to go taller. All right, so here's your spine. You get the bones here, the vertebrae, and there are little cushion pads in between them. To take up some of the gravity's pulling your, trying to squeeze your back down. So those pads, cushion pads in between there, they keep your bones from scraping together. But when you're up in, say, in the space station, up in free fall, you don't have that downward force anymore. So eventually those pads will relax a bit and your spine will stretch out and you can get up to about 3% taller over a year. And once you come back down to Earth, it takes a little while to get back down to your normal size. Excuse me. Now here's a couple of guys, Scott Kelly and Alan Kelly, and they're identical twins. And this guy, he was up, they're both astronauts. He was up several years ago. They wanted to send Scott up, right? So they want to do this twin study to see if there's any short-term, long-term effects. And they're going to have the sort of the same constitution with them. So they started doing tests on them down on Earth, whole set of tests for everything. How your body works, your heart rate, this and that, a lot of other things, blood work. And then Scott was up for a year, and those tests continued. He was having his done up there, and his brother was having them down on the Earth. And then when Scott came back down, these tests are going to continue for quite a while, as long as they can, just to see if there are any long-term effects. And when Scott came back down, he was 2 inches taller than his brother, whereas they're the same height when he went up. All right, your muscles are going to lose mass, and you don't have that downward force on your muscles, so you don't have to use as much strength to do any work up there. There's still momentum for everything, but you don't have that force you have to deal with. So if your muscles aren't going to be used as much, you're going to start to lose muscle mass. So you don't need as much to support your weight. So you're going to lose the mass, you're going to lose some strength. And that's not all. Your bones lose density. You don't have your legs, bones in your legs, you don't have that weight pressing down on them anymore. So your legs and hips and your spine no longer weight bearing, so they're going to get thinner and lose maybe 1 to 1.5% per month of the mineral density. So your bones are taking in minerals, calcium, phosphorus, for good bone strength. And so if they don't need that extra, those extra minerals coming in, they're not going to take them up, right? So that calcium and phosphorus and Any other minerals are going to stay in your blood, right? And eventually wind up in the urine. So that can cause some problems if you're not taking up as much calcium. Calcium can wind up in your kidneys and you get kidney stones. And that's not something you want to have happen when you're up there in space station. Right, so what they can do about that, they want them all to do a couple of hours of exercises up there every day. So there's aerobic training or aerobic exercises to keep your heart going, keep your heart strong, and resistance training to build up maintain your muscle mass as much as they can. Right? And they're also analyzing urine for calcium, so they can do the urine analysis up there. And they're always in contact with medical professionals down here on the Earth who are analyzing all this and watching the astronauts for different things. Right, so they want a couple of hours of that. They did a test to see which is better, maybe some high intensity exercises for a short period of time or moderate intensity for a longer period of time. And turns out either one is about the same benefit to it. So they decided to go with the high intensity for a shorter time. And so they're spending less time on the exercise equipment, so there's more time for them to do their work there in the space station, but also it's less wear and tear on the equipment. Right, here, that's one. Okay, another thing that happens, your face gets puffy. Right, so we're mostly liquid, right? And gravity's tending to bring a lot of that liquid down into our legs. Right, so if you're up there in free fall, it's no longer drawing it down there, so that liquid tends to come up and disperse itself around your body more evenly. So some of that will come up into your face, and your face is going to get puffier. And it might, after a while, it might go away a bit, but it's always going to stay a little bit puffy. And with less water that down there in your legs are going to look skinny. So they call it the puffy face bird leg syndrome they have. And take a look here, see this guy's legs. Those legs look kind of skinny. And you see these bands on here. These are compression straps that they can wear to keep more of the fluid down in their legs, so they're not going to get the skinny leg syndrome quite as much. There's a caricature here of what happens to you. It looks like it's a little bit exaggerated, but on the ground before you go up and when you come back down, you're normal. But once you first go up, a lot of that water comes up, your legs are skinny, and your face will get puffed out, and you'll be sort of barrel chested more. And after a while up there, it settles out a little bit, but it's still more water up where it normally is. Right, without all that water coming up where it not normally is, you're going to see more of it up in here in your face, and some of that can get around the eye. Right, so it is studied about 27 astronauts, and 9 showed they have bloating around the optic nerve, which is just in behind the eye. It's actually part of the brain, the only part of the brain that's not in the cranium. And 6 of them had their eyeballs were flattened at the back, so they think that is all due to the extra water there in the head. Right, and they found that swelling in the back of the eye has been fairly common with the astronauts. So they can do testing for that up there. You see a piece of equipment here that they can check out the eye on that. And this one has a lens attached to a tablet. And so that can be sent down to the Earth, and doctors can be doing an eye exam on the astronaut in pretty much real time. So they're always checking the eyes there because they don't want the astronauts to have defective vision when they're out there because they have a lot of important work to do. Right, it affects your sleep cycle. Cool. All right, when they're trying to sleep up there, you're not going to sleep while floating around. So a couple of things they have here is that maybe one of the older beds where you're strapped in like that. In a case like that, they found once you fall asleep, you're not controlling your arms in with that. So your arms start to float around, and your head will bob around like that, but you're not consciously holding them back. But rather that astronauts have woken up and sort of been momentarily frightened by these arms in front of their face. It's their own arms. And it's going to be they're lighting up there. They try to keep it down a bit for these sleeping areas, but you have you wear the mask here like that. That'll make it darker. It's going to be loud up there, particularly there's fans going all the time. And so they maybe try to keep that down a bit where it is where they're going to be sleeping. And to get away from the arm problem, here's another one here. It's probably Velcro. You strap your attached into there, but you can bring your arms inside of it there. So they want the astronauts to get about 8.5 hours sleep per day, 24 hours. But with all that's going on up there and the difficulty in sleeping, they only get about 6. And one of the big things about that, you're not going to get 12 hours of daylight and 12 hours of nighttime up there. It's orbiting about every 90 minutes. You're going to have a 45-minute day and a 45-minute night. And that's really going to throw off your circadian rhythm, which we all have. And we're used to having that in our eyes. We have the rotten cone cells, but there's a third kind of cell that will recognize twilight. And that's a trigger to start the melatonin production, the hormone. And while we sleep, having our deep sleep, that melatonin works to repair the cells in your body. And so you need that good sleep there to have your cells repaired and keep you healthy. And they're not going to get that as well with like 45-minute days and 45-minute nights. So they have to pretend they're at nighttime with maybe blocking out the light as much as they can. Coordination goes way off when you're up there until you really get used to it. So it's going to take a while to get used to being in free fall. And then once you come back down to the earth, you probably have less muscle mass, probably have not as strong bones. So when they come down there, you're suddenly back in 1G force there. So they don't really let them come out of the capsule and go walking because they're going to be very uncoordinated and probably have a serious fall. So put them in chairs and carry them away until they get used to the gravity. All right, so it can mess with your immune system, that system that does the repairs for us and keeps us healthy, fighting the germs that we get, that sort of thing. So there's a lot going up there. The talk about the disturbing the sleep cycles. It's going to be a lot of radiation in space, and we'll see that coming up. A lot of germs up there, and you're stuck in this big tin can world, big can, and with 5 or 6 other people. And somebody gets sick, we're in a closed system. That's everybody might get sick from that. So just all of that, the isolation, you're completely different to what you're used to. So that can affect your immune system, and it could suppress it somewhat. And you're at risk of getting infection. You have these autoimmune issues, some old viruses that have been sitting around, maybe been vaccinated against them. Some of these can reawaken if your immune system goes really way down. And there's some thought that it might be supercharged as well. Maybe it get more aggressive. They've had some astronauts that have shown to have rashes and allergic reactions. And that could be due to an over-aggressive immune system. All right, bad one here. Your senses get dulled. You probably look forward to having your meals when you're up there. Good time to be sitting down with a couple other people and relaxing a little bit. But with that extra water in your head, right, a little bit, it's kind of like having a bad cold. Right? Your nose is going to feel stuffy, and your taste is about 70% smell. And if you can't smell properly because of the extra water up in there, your food is going to taste bland. Right? Now you see a bunch of them here having their meal, and here's Chris Hadfield showing off his tortilla taco. Right? And see that in a minute. And so I think Chris was allowed to take up some hot sauce as part of his personal luggage, and it makes the food maybe taste a little better, which could be very important if you don't want bland food. All right, a little bit here in the food. There's it's not eating like eating out of a toothpaste tube anymore with some indescribable white stuff coming out. Maybe what they usually have, but they're always looking to improve this part of it. It's really good for morale, and you really want some healthy food out there. So you want food that's tasty, nutritious, compact, because you need it. There's not a whole lot of space up there to store it, at least inside, and lightweight. So you're not the heavier things are, you're going to have more blast power to get off. And one thing that's the reason that Chris Hadfield was making something out of a tortilla said you're not allowed to have bread up there. Bread crumbles, and you get some crumbs there, and they're going to be floating throughout the space station, maybe screwing up the ventilation system, things like that. So no bread is allowed, also no alcohol. And so there's a lot of different things they can have up there. They say your best friend up there is a pair of scissors for opening your food packs. And it might be freeze-dried food, and it could be taking the water out of it, dehydrated food. So they do have a rehydrator up there to put moisture back in. And there's the equipment up there to reheat your food as well. So they do what they can to keep the astronauts feeling well and staying nutritious. All right, this is the tough part. They say it's the hardest thing they've ever done, many of the astronauts. Psychologically, you're isolated away from your family. You can be talking to them at times because you don't get the internet connections. But if there's problems down on the Earth, there's not much you can do about it. Right? You're confined up there. You're with 5 or 6 other people. Hopefully, they're all getting along. There could be conflicts that arise, but they encourage them, not to take it out on each other. Actually, encourage them to keep a log or a journal. So if you're having a problem with somebody, you get it out by writing it down. And so the longer you're up there, the worse this is going to get. So if you're talking about 6 to 8 months to get to Mars, this could be a significant factor. You don't want someone going wacko on the way there. So of course, everybody is going to be astronauts. They're going to have these personality tests before they go up. All right, you're running into certain dangers in space. All right, these could be meteoroids and debris. All right, so any night you're out in a dark sky, you're going to see 4 or 5 or 6 meteors every hour, depending how dark it is. And so space is filled with tiny pebbles coming in from outside. Even some are quite a bit bigger. And they're traveling very, very fast. We're traveling 30 kilometers a second. Right, so anything up around there is maybe traveling even faster. And energy is formula for kinetic energy, 1/2 mv squared. Right, so we have 2 little pebbles, and one of them weighs 10 times as much, the other is 10 times as mass. It's going to hit with about 100 times the force that the smaller one does, the lighter one. Right, so these things zipping around space, if they hit the space station or whatever capsule happen to be in there, that could cause damage, possibly break through. And it's not just the stuff from there. We're putting up a lot of crap in space called satellites. And even a few years ago, we'd already put up more than had gone up since the first ones went up in the late 50s. And the numbers just keeps increasing, and most of it's the Starlinks, trying to count them up here. Right, so the more and more we get up there, there's greater and greater chance of collisions. And there have been satellite collisions before, and some have been shot up just for target practice for countries. Right, so there's a lot of, they're trying to keep track of all those little bits of debris up there, but there's far more up there than they can keep track of. Right, so here's tracked objects from 1960s, keeps rising up. Right, get some debris here. There's a weapons test here from China. The States had one earlier. Space, it was down at quite a bit lower altitude, so things came down fairly quickly once they get into the atmosphere and burn up. Here's a radium and cosmos collection a few years, maybe 15 years back. Right, that made a big jump in things. The total just keeps going up. So there's a lot of, even a little paint chip like that traveling at 30 kilometers a second, that's going to hit with a whack. And if you got people doing extravehicular activity outside the space station or whatever, they get hit with one of those things. Could be game over. All right, so they have the ability to move space station if you see something like that coming. Maybe raise it a little bit or get down. But these are the ones that they're tracking. And I think they've had to do that before. You're in a closed environment, so they can't open the window, let fresh air in. Right, so you're heavily ventilation system up there. So the air is filtered and controlled for temperature and humidity. So it's taking water out of the air. It includes an oxygen generator. So it's taking the water out, moisture out of the air. That runs through electrolyzer and takes the hydrogen and oxygen, separates them so they can vent the hydrogen, and the oxygen gets reused back into just regular ventilation, keep the oxygen levels up. They also have some backup oxygen tanks there as well. Any germs, microbes. Somebody has something and gets into the ventilation, it's going to come around, and everybody can get it. So sicknesses can get worse up there. If you have allergies, usually they're going to test for that anyway before you go up. But you can maybe develop one up there, and that could worsen. Now, if you're probably thinking this, I'm not sure how bad it is now, but years ago, it was pretty stinky up there. They have charcoal filters up there to remove methane from farts and also remove the ammonia from sweat. So I try to what they can to keep the bad odors down to a minimum. And the really big danger is radiation from space. And this is in particular if you're going on a long, long voyage, say to Mars. And I'd say these could be extremely high-speed particles from outside the solar system, protons, neutrons, electrons, atomic nuclei. A proton is just the nucleus of a hydrogen atom. Alpha particles, the nucleus of helium atom. Strip the electrons off, but they're even larger ones like that. They could be carbon nuclei as well, or oxygen. And they're coming very, very fast if they're coming from outer space, maybe from a supernovae or something like that. Celestial electromagnetic waves, X-rays and gamma rays, coming from very, very hot things in space. Supernovas, just minutes after that, gamma rays forming from the shock wave coming out. And so these could be coming in from anywhere. Now, our atmosphere will protect us from the X-rays and gamma rays. So they won't get through the atmosphere. The other ones coming in, they would have collisions with the particles, the atoms in the atmosphere. We get secondary radiation from that, be creating, say, neutrons, which could cause radiation damage to us. And they make a whole dog's breakfast of secondary and tertiary cosmic particles that do come down to the Earth. And we get radiation doses from that. So radiation doses are measured in what's called sieverts or grays. Now these are very high doses of radiation, a sievert at joule per kilogram. And most of it is measured in millisieverts or microsieverts when you're talking environmental. Talking about maybe personal radiation doses, it could be in low millisieverts. And environmental ones are talking in microsieverts. All right, so radiation can transfer its energy. Some of this is kinetic energy. Others of it could be ripping off the sun, electrons from cells in your body. Right, so that energy gets transferred to the body cells, and that could destroy the cells or mutate them. Right, and during the night, maybe some of these are going to be regenerated or fixed there, but if you get a lot of it, your body can't keep up with the repairs. Right, you could have to mention protons are positively charged, electrons negatively charged, so they could knock an electron out of a molecule. That electron might be holding the molecule together, so it breaks that bond. Right, now, if this is your DNA, you could have that damaged DNA in there, and it might come back reunite, but in an improper manner as something else, and maybe cause cancer, or you could have maybe a mutation from it. So your short-term effects from radiation are you get really, really high doses. You're talking about a couple hundreds of millisieverts or milligray of radiation dose. You could have depressed blood counts. More than that, you start to work into damaging your gut like that. So typically, I think it's about 4.5. Get an acute dose maybe over one day of about 4.5 gray. 4.5 sieverts, you have about a 50% chance of dying within a month. So the old rule of thumb is if you throw up on the first day after a huge exposure like that, you're probably not going to make it. And there are long-term effects like heart disease and cancer. A dose of 200 to 250 millisieverts over your lifetime will increase your chance of cancer by about 1%. And we all have about a 25% chance of dying from cancer. Right, so if you get about 200 and 250 millisieverts of lifetime dose, that goes from maybe 25 to 26%. The more it is, the higher the chance is. All right, so where does that all come from? So we got Earth's radiation belts here, the Van Allen radiation belts. We have the inner one and the outer one here. This one runs about 1,000 to 12,000 kilometers above the Earth. But it does reach down toward the poles, it's closer, and there's what's called the South Atlantic anomaly, where it can get down to about 200 kilometers latitude. And that runs from the middle of South America across the Atlantic Ocean and just down to the southern tip of Africa. And the space station passes through that. Right, just down that low. So the astronauts in the space station get maybe half of their dose going through that South Atlantic anomaly. And so these are protons and electrons in here, and mostly electrons in the outer one up in here, which goes from about 13,000 kilometers up to 40 or 50,000, or yeah, kilometers high. Right? The sun gives us radiation, as do the cosmic rays from outer space. A picture of a Crab Nebula in here, and this is taking an X-ray to the blue part that you see. Right, so I've mentioned where these come from supernovae, the active galactic nebulae. So you get all these high energy particles coming in, plus the electromagnetic radiation. And here's the sun. All that solar wind, that's protons and electrons. And now our magnetic field will tend to keep us safe from a lot of that, but you get a huge flare, and that could suppress this and throw a lot of stuff. That's what gives us the northern lights from say our latitude. So there's one nice thing about it, but there could be, well, the space station's well above our atmosphere. Right now, halfway between Apollo 16 and Apollo 17, there's a huge flare from the sun. And they said if there had been astronauts going to the moon at that time, they could possibly have received a lethal dose of radiation from that flare. And if you're going to Mars or somewhere like that, it's going to be quite significant. You're there for a long time. Now, the space station does have a safe spot where there's extra shielding and maybe avoid most of that from the sun. And so here's what we typically get. Cosmic radiation dose, normally we get maybe 200 or 300 microsieverts per year from the outer space stuff. Most of that would be from the secondary radiation. Right, our average dose would be about, all of us get 2 or 3 millisieverts a year. Some from that, some from ourselves, and we get some, a lot of us from radon. There's a lot of uranium everywhere, so we're getting some from that. And radon gas is quite nasty, depending on what you get for ventilation in your house. So you can get maybe half of it that we get is from radon gas. So we're all getting 2 or 3 millisieverts a year. And let's see, abdominal CT scan, we're up to about 9 millisieverts from that. Radiation workers, I worked at Point Pro, so as a nuclear radiation worker, the limit is 20 millisieverts per year. Very, very rarely would anybody get that. Maybe the higher work groups might get around 10 to 15, but most people get much less than that. At 6 months in the space station, you're looking at about 80 millisieverts. All right, so they have different dose limits for astronauts. Trip to Mars, 6 months, 180 days, 6 months. You're looking at about 200 millisieverts. That's over a long period of time. All right, so for one trip to Mars, give you pretty close to a 1% extra chance of getting cancer. And if you're spending that length of time on Mars as well, maybe if you're not underground, you get about the same as well. So radiation is it's perhaps the biggest danger in space. All right, so who wants to be an astronaut? Nobody. Okay. I'm too old.
Interesting stuff.
Wow. It almost makes you not want to go.
Yeah.
Oh,
You made it sound like so much fun.
Yeah, no.
I like the part about the legs getting skinny and the chest getting big, but other than that,
Face getting fat. Well, that's happening now.
Yeah, I didn't show the toilets up there, but
yeah.
Yeah, probably better off.
yeah,
So it
that's
takes methane out of the farts. That's good too, eh? Yeah.
pardon me?
It takes the methane out of farts. That's another good thing.
Yeah, well, it doesn't, yeah.
Yeah, space station. Yeah.
I hear there's a little sign over the toilet, so it says, "We aim to please. You aim too."
Yeah, yeah, you look on seeing the NASA site, they got lots of videos up there of how to use the toilet on there, and
Yeah.
you got the little suction cup, and you have to get really close to that. Otherwise, I might have seen in the first slide a little drop of water there at the astronauts face upside down in it. So you get little drops of urine up there.
Hmm.
It's hard to pick up, so they have to clean that up. They get wipes and stuff like that to collect it. Takes a little while to use that.
They recycle most of the water anyway, right?
They do, yeah. So they recycle the urine, they take the bad stuff out, and the water goes back in.
Today's
Just like
coffee,
they do.
tomorrow's coffee.
Yeah.
Maybe
Maybe there'd be enough coffee in what you get rid of to make their coffee a little bit stronger every day.
when you talk about the Van Allen belts, now
Yeah.
you said that they pass through those. They're closer to the planet at the
They're in
pole,
that one area, yeah.
so they would pass through them a number of times, I guess, would they?
Yeah.
And that's all considered in their exposure for a year.
Yeah, I think it was around 50% roughly, give or take 10% of their dose that they pick up there is from that particular area.
So, what are your thoughts, Kurt, on us traveling to someplace like Mars?
I don't think it's going to happen for a while yet.
Yeah.
They get big ideas, but if you want to do it safely, there's a lot they have to do. I just saw in the last few weeks or so, they get a picture from the orbiter of looked like a tunnel on Mars. So it's going down. They could see down below the surface. There's some ice down below that. So it looks like there's a hole down there. So if they have tunnels, that'd be the logical place that their astronauts could get in that and build it. So then they're safe from the external radiation there.
Yeah.
And they'll look to do the same on the moon.
Yeah, probably will, because there's no protection there either. I seen a post about the Starship. Actually, instead of it standing up on the moon too, they were talking about having it lay down like horizontally. Give them more space on the moon.
Yeah.
How they do that, I don't know. How they get it back up again to take off, I don't know.
Just ropes and pulleys.
I suppose, yeah.
You get 1/6 the gravity there, so it wouldn't take quite as much.
Right. Yeah, it'll be interesting. I mean, I don't know if we'll get to Mars in our lifetime, but maybe it will. I know he's pushing. He wants 1 million people on there by 2050, is it, or something like that?
Who does?
Musk, I think. Yeah.
Oh, I thought the guy that owned the Gulf of America there.
Oh, he would require 1,000 starships apparently. How he's going to do that, but I don't know. We'll see. Yeah, so it is an interesting place to be for sure, and I mean the kids like to talk. I'm sure.
Yeah.
They'd like to know what it's like up there. Not quite the same when you're doing the 5 minutes up and the 5 minutes down kind of thing, right?
Right.
Yep.
My wife and I can't stay in the house for 2 days straight, let alone 7 months in a little capsule.
Yeah. No smoking either.
Yeah.
Didn't they have a test site where they had put 8 people into it and had left them in there for a few months or something to see how they could?
Yeah.
Well, the Russians did.
Well, I think there was an American one. They did it too.
Yeah.
Locked them in for 8 months, I think, and just to see how they could.
Yeah, in the desert, wasn't it? Yeah.
Yeah. So it's a sample, I guess. I mean, you're in a tin can, heading 8 months to Mars too. And then when you get there, you're still with the same people for another 2 years before you can come home. So interesting. All right. Thanks, Kurt.
All good.
Talk there. Let's go on to Final Bud.
I know, but
Bonabud.
Final bud.
alrighty, binocular target of the week by Bonobud is the head of the serpent. And they took my coffee. Anyway, the head of the serpent asterism. To this, I love the way this blocks off the corner, and I can't read my own stuff. But it refers to the stars forming the head of the serpent in Serpens constellation. This asterism is part of Serpens Caput. I would think that's how it's pronounced, right, Kurt? Caput?
Yeah.
Right on. Which is one of the two parts that make up the constellation Serpens. Serpens Caput, representing this, the serpent's head, is located west of the constellation Ophiuchus. But how would I find it in the sky, you say? Well, if you're at 10 o'clock tonight, guess what? It's going to be clear, even though it's windy. Orient yourself east, southeast at 105 degrees, look up, and you will see maybe the Keystone of Hercules. You'll see Corona Borealis, and just draw a triangle between the two, and it brings you right over to the head of the serpent. Right here. And a closer look, just it's these three stars that make up the part of the constellation. They had this one for the head of the serpent, I guess. What does it look like? There's the three bright stars there, and there's the fourth star. It's dim, but that's the head right there. And then the body comes down and goes away, but we're only looking for the head of the serpent. 10 by 50 binoculars. Large object, easy to see. You'll know the four stars when you're on it. It almost makes a perfect square, but not quite. Compared to the full moon, what, 7, 10 full moons across. So you're not going to have a problem wondering if you're on it or, you'll be able to see it. How's that? And are you ready for this one? What do you call a snake that is 3.1 meters long? A python.
Oh,
Yeah.
oh man.
And that's Binocular Target of the Week by Bino Bud.
God, it looks like a pyramid.
I think I've just gone weightless.
I was thinking it looked like a pyramid.
A python.
Python. Oh, good God.
Nice. Okay. Thanks, Mike, I guess.
Yes.
And you want to change this up?
Yeah.
You think it's going to get better?
What am I thinking? Yeah.
Oh,
Okay. Mr. Paul, how about Rosanna's
yeah,
fun?
sure. How do I follow that up?
Well, you'll do it.
All right. This is this week's
Rosanna's Fun Fact.
Oh, hang on. There we go. Put things back so I can see where I'm at and stay where I'm to. All right. Well, welcome back, Rosanna, for another great fun fact for this week. And as usual, Rosanna keeps things pretty much in timely fashion. Whoops, just a sec here. I'm pressing right buttons and wrong buttons and everything else here. Just give me a second to figure out where Rosanna went. There it is. All right, let's start there. Okay, so Rosanna writes, hi Paul, in honor of Mother's Day, I thought I would cross into some light and some dark territory. Vera Florence Cooper Rubin, who died at age 88 on December the 25th, 2016, was an American astronomer who pioneered work on galaxy rotation rates. Now, she uncovered the discrepancy between the predicted and observed angular motion of galaxies by studying galactic rotation curves, which is what you're looking at here. Now, the rotation curve of a disk galaxy, also called a velocity curve, is a plot of the orbital speed of visible stars or gas in that galaxy versus their radial distance from the galaxy's center. It is typically rendered graphically as a plot, and the data observed from each side of the spiral galaxy are generally asymmetric, so that the data from each side are averaged to create the curve. A significant discrepancy exists between the experimental curves observed and a curve derived by applying gravity theory to the matter observed in the galaxies. The dark matter is postulated as the main solution to account for the variance. So what you're looking at there, there is a still from a 16-second video. Now the one on the left, a simulated galaxy without the dark matter, and the one on the right, is a galaxy with a flat rotation curve that would be expected with dark matter. And it's showing obviously the two different curves, one with and one with the matter, one without. And of course, this is theorized. So honored throughout her lifetime for her work, she received the Bruce Medal in 2003, the Gold Medal of the Royal Astronomical Society, and the National Medal of Science, among others. The Vera C. Rubin Observatory in Chile is named in her honor. Her legacy is described by the New York Times as ushering in a Copernican scale change in cosmological theory. To sum it up, it is her work, albeit very complicated work, that is cited as evidence of dark matter. Dark matter density is the solar system in around 0.3, and I can't say what that is. That's a lot. In terms of mass, it means that the Earth contains one squirrel worth of dark matter at any given time. Wow. Is there any way to find out which squirrel it is? No, it's not literally. Oh, that explains why they weigh enough to set off those spinning bird feeders. Dark matter isn't squirrels. Vera was also the mother of 4 children who all have PhDs in science. And not only were her children greatly influenced by her, Rubin spent her life advocating for women in science and was known for her mentorship of aspiring female astronomers. Rubin is widely regarded as having been one of the select women in science who were overlooked for the Nobel Prize on the basis of gender discrimination. This probably added to her determination to support and mentor other aspiring female astronomers. Her life was not all roses and awards, and her work was dismissed and considered controversial in the beginning. And now here is where we truly leave the light and head into the dark matter. The creation of the Rubin Observatory in Chile is still more or less on schedule, showing that astronomers and workers have a sense of humor. This picture was tilted and it needs some assembly. Now I'm going to see if I can show you this. I hope it's there. There we go. So here is a schedule of completed elements listed on their website with first light scheduled for this July. So there's all the things that are completed and all of the things that are yet to come. And on July the 4th, 2025, the schedule for the Rubin first flight is ready to go. But as part of a broad push by the new U.S. administration to dismantle DEI, which is diversity, equity, and inclusion programs, the biography of this renowned astronomer, Vera Rubin, for whom the federally funded Rubin Observatory is named, has been altered on the observatory's website. All mention of the championing woman in science and any mention of the observatory's efforts to reduce barriers for women and other historically underrepresented groups have been removed. Astronomers worldwide are expressing disappointment and alarm. This is the story of what happened in her life. Yvette Sendes, a radio astronomer at the University of Oregon, told Space.com she was a huge champion for women in her science, and in particular, she faced things that were discriminatory for women. Diminishing those stories is pretty disturbing. Another one quotes, "No executive order, no political etiquette is going to undermine or end our efforts," astronomer John Barentine told Space.com. If anything, it is giving us more encouragement to continue to do this work because it is the morally, philosophically, and politically right thing to do. Job descriptions and staff bios of workers at the observatory have also been altered to exclude any mention of diversity or exclusion. Now, however, Amazon.ca and .com still offer this, which is the stuff between the stars, and this is how Vera Rubin discovered most of the universe. And this, a Physics Today Best Book of the Year winner, Vera Rubin, A Life by Jacqueline Mitten and Simon Mitten. So in spite of efforts to alter or change the truth and to quash achievements, astronomers are at every variety worldwide will continue to share knowledge in every form possible. They all know how many colors and flavors of gumballs exist in the world. Hey, mommy, it says that in a campaign against diversity, we are now subject to only one flavor of gumballs. And that's this week's
Rosanna's Fun Fact.
yeah. Now, there you go. So there's what's going on down south of us. And it's just all these amazing accomplishments by these people, regardless gender, regardless of anything. These are amazing accomplishments that never would have happened had it not been for this woman and what was going on and what she's done. And they're even talking about decommissioning or defunding the James Webb Space Telescope. So anyway, enough said about that, but awesome work, Rosanna, on that, because that is very enlightening, and go girls go.
Yeah. Oh, I'm not going to go down that road. Keep my comments to myself. Oh, it's just,
There you go.
it's shameful in my opinion. Just,
Yeah.
it's wiping out parts of history.
Well, it's the trouble is just that there's so much more to be discovered, and a lot of things won't be just because of biases. So anyway, so I just say keep up the good work. This too shall pass, and we will continue to do what we do with astronomy, and our efforts will always move forward on that, I think.
Absolutely. Thank you, Rosanna, for another interesting topic. Timely for sure. Okay, let's get to some photos then.
Yeah, pictures are good.
These are always good.
Don't forget, Chris, at the end, I got one I got to show from
Yes,
Kim.
yeah, for sure. West, and I'm gonna go here. And it's my share my screen. How about we share this one? Here. How's that? Pop up?
You Yep.
Okay. All right. Well, we get this picture from Robert Gadet. Robert said this is a picture from the sun taken on May the 5th, showing sunspots from left to right, 4082, 4081, 4079, 4083, 4076. I'll agree there. 35% of 728 frames stacked in AutoStacker 4, processed in IMPPG and Photoshop, and using a C-Star S50. Sunspot 4079 is 7 times larger than yours. Now that's pretty well rotated over to the side now. It's not going to be any threat to us now at all.
That's a nice definition in that picture, though.
For sure. Now remember, it was a year ago today that we had all that big show last year, May the 10th, May the 11th.
Yeah.
G5 level activity.
I saw that post you put up. Yeah.
I mean, it was. It started on the 8th, I guess, and we had a number of 7 X-class flares altogether, and countless M-class flares, and they all kind of headed towards us in the same pattern. And away we went. We had the best show in 20 years.
Yep.
So, there was a lot of hope with this one, I know, but it's I don't know, what is it, Kurt, that get these big sunspots and there's just nothing from them? Is there a particular reason, or
Just chance.
Pure luck.
okay, we'll chalk it up to that.
Yeah.
Thanks, Robert. And here's another one from Robert from a nice moon capture here. 64% phase. He said 16% of 730 frames stacked in AutoStacker at 4, processed in IMPPG and Photoshop. Great job, Robert.
Yes, sir.
Nicely done there.
Good.
There's so much, there's just so much to enjoy about the moon. Like there's just so many areas on the moon. You just want to take one section and study that one part. I mean, every night, it's like, to me, it's like going bowling. You throw a ball down in well, like I do, I hit the gutter most of the time. You can always hit the button and then it'll start back up again. But this is kind of like the moon. I mean, the moon's different every night. So
Yeah.
you've got a different view. So you've always got something new to challenge you to enjoy. So great shot, Robert.
Nice shot.
Kathy Adams here from the Sun on May the 5th. Here's the ones that Robert had mentioned, the
There you
labels
go. Yep.
on them. Nice to meet Kathy. And another capture from Kathy here with Whirlpool Galaxy.
Ah, there you go.
Finally had a chance to process 2 nights worth of M51, about 4.5 hours integration time, using a Dwarf 3 with Serial and Photoshop. The skies were moderately clear, she said, 30 seconds exposures and a gain of 60. Nicely done.
There you go.
Love that one. That's a fantastic one.
A little galaxy just below it too. There.
Oh, down here, yeah.
Yeah. Right on.
Yeah, nicely done. All right, I'm going to go to David Samar's capture here of the Sun on May the 6th.
Yeah.
More of that 4079, big one there.
She's a big one.
I'm going to go back to this one. This one was sent to me last week. I didn't get it on the show from Francois Theriault. And this is, of course, M13.
Very nice.
So, yeah, I mean, it's amazing to know there are balls of stars like that in space. You know, you look through the eyepiece and you see something like the Ring Nebula, or you see something else, a galaxy. But then when you see these, it's unbelievable. I always picture that, here I am on a star or on a planet orbiting a star, and here, what would my sky look like, in the center of all that?
Yeah. Was it daytime all the time?
If you could survive the radiation, I guess, first of all, but amazing capture. That's one of the prettiest globular clusters, of course, in the sky. Great one for Francois.
Hmm.
All right, going to go to Emma. Now, Emma McPhee sent these ones in. She said, sunrise. She says, follow the sun's path towards northeast till June 21st. To the right of the Assumption Building, March 29th. So, hang on now. There it is, to the right of the Assumption Building on March 29th. Sunrise between the Bell Tower and the Assumption on April the 12th. So go back one.
Yeah.
So here she is to the right of the Assumption Tower, and then Assumption Tower's here, yeah, and then between the two towers. Then sunrise to the left of the cathedral on April 21st, which is here. And then sunrise again on May the 5th, with the cathedral to the right. Oh, did that one go? Oop, did I lose that one? I did, there it is, cathedral to the right. So she said she wonders how far northeast the sun will rise until June 21st. I think it's another 10 degrees or so before June 21st. But yeah, I mean, we can guess the fact that the sun is rising in a different location throughout the season. Kurt, want to comment?
You gotta get up early in the morning to get a shot like that.
Yeah, for sure. This time of year, for sure. Nicely done. Thanks, Emma. I'm going to go to Deanna Kings now. She sent these ones in. She says, I saw this on May the 5th from my deck in Keswick around 11:15 p.m. So she got a nice little meteor stretch there during the meteor shower. Nicely done, Deanna. The Powell's capture of the moon here, the mineral moon. Oh, you guys are all muted. Oh, Mike's
Oh,
muted.
yeah. There we go. We're back.
Here, you're back now.
Ah.
Okay.
Everybody back. Hey, everybody's back. Hey. There you go.
Yeah, they renamed the color of the moon to a mineral moon. So that's a mineral moon.
That's really neat. I like that.
It brings out a lot more.
Maybe sometime you could name all the minerals that are the different colors that are on there.
Yeah, and where they are, Mike, too, please. Yeah.
They're on the moon.
Label them all.
There's blue ones and red ones and brown ones.
Nicely done. And here's this capture of the.
Yeah, we did get rain the next day.
We did rain the next day. Yeah,
Yeah.
not a good sign, but beautiful to look at and photograph. A circle of light around the sun, known as the halo or sun halo, is an atmospheric optical phenomenon caused by the refraction of sunlight through ice crystals in the atmosphere. Now, these ice crystals, typically found in thin cirrus clouds at high altitudes, refract sunlight, creating a bright ring or halo around the sun. Now, while it can sometimes be a sign of an approaching weather front, especially an indication of rain within 24 hours, it's not always a guarantee unless you live in New Brunswick.
So, Kurt, on that, does it have to be a specific height in the horizon to be able to get that effect?
But the halo,
Yes.
well, it's a 22-degree halo. So if it's low, sun is low, the sun or moon is low like that, you're not going to get the whole thing. So with that particular one, there's really no height one for it.
Okay, so there's no specific angle from the sun, because I know with the rainbow, for example, I think it's what 23 degrees or something.
Well, it has to be 42 degrees above the horizon to
Yeah.
get that. Yeah. But with the halos, you're looking toward it, toward the sun or the moon. With the rainbow, it's behind you.
Okay.
Right. Awesome. Mike?
Now,
Yeah, very
Brian,
nice.
Brian Stone and Moncton, I think it might have been on Wednesday or Thursday. So when you got this one, Mike?
Yeah, just this week before our rain there.
Brian had a very rare one. He had two other halos within that one.
Oh,
I
really?
think one
Yeah,
9 degrees, I think the other one maybe 17 degrees.
right on.
So he asked me out, and I had to look up to see. They call them um, odd radii halos.
Okay.
Yeah, it's quite different. Fairly
I'm
rare.
sure it would be.
Yeah.
That'd be cool to see.
Yes, sir.
Yeah.
Got a picture of it if you want.
Yeah, email it to me. I'd like to see it.
All right.
I'm going to move ahead to just one more here from Mr. Paul Owen.
Oh my goodness.
Oh,
Eagle
Okay.
Nebula.
It's not always about, I mean, nature is more than just night sky. So just had to share that. Just a fantastic capture, Paul. It's
Oh, thanks. Yeah.
unreal.
there's
Unreal.
more of them in Canada than the States too, for some reason.
There's no shortage of I'm out here in Hampton, of course. And if you go down on the river in a boat, there's no shortage of bald eagles. There are so many now.
Why are they bald? I see hair on there, feathers on there.
Yeah. But that's a nice mature bald eagle. That one's they're nice to watch. They've got this really intent look in their face, especially in their eyes. So they're really kind of creepy when you first see them with them and you look at their talons.
I'm gonna say, wouldn't you be a little nervous? He could pick you up and carry you away.
It's amazing to watch them because they're so graceful. I watch them and I watch the osprey fish.
Yeah.
And the eagles are probably, I bet you, 50 to 60% better fishermen than the osprey are. Because the
Really?
osprey will drop and they'll hit the water, and a lot of the times they'll come up and they won't have a fish. But the eagle doesn't splash like an osprey does. It just kind of glides down, throws its talons in the water, and just kind of comes up again. And it's just so graceful to watch. They're just an amazing thing to watch, really.
Great capture, Paul.
Yeah, thanks.
All right. Now I'm going to stop sharing for a second because you got a picture to share.
I do.
You do that.
Yeah, I'm just going to share this just for a second.
Pictures here in a second.
And this is sent in by Tim Doucette, our friend down in, just a sec here, I got to get the information up again. My phone timed out. Down in southern Nova Scotia at Deep Sky Eye. Tim writes on this one, he said, this is a photo for you guys. It's called the Polaris Flare. And it's a filamentous gas cloud in the Milky Way, which can be seen in the Little Dipper, or Ursa Minor, and around the star Polaris, which of course is right dead center right there. And it's estimated at 50 square degrees. The range is approximately 500 light years, taken with a Canon R8 plus 135 millimeter f2 lens, shot it on a tripod with no tracker. And he captured 359 20-second images for a total of 1.8 hours and processed in PixInsight. But that's a wonderful image of that whole section of the sky, Tim.
Look at the stars. Wow.
Yeah,
Easy.
unbelievable. Very, very well done. And there you go. All you need is a camera, tripod, and a little bit of patience, and you can capture beautiful images like Tim did.
Awesome.
Some dark sky would help.
Yeah. He's got
Yeah,
that.
dark sky, absolutely. So there you go.
All right. Let me get back to where I was there, and I'll continue to share just a few more. And I think all I really wanted to do was this one. This is probably one that everybody knows anyway, and that's to be sure that if you want to have any photos that you'd like to share, please send them in to astronomybythebay@gmail.com, and we'll be happy to put them up in our next broadcast. And I'm going to bring on something here from Kurt up on his article tonight. Hang on a sec, where's my notes here? Kurt puts out a weekly WhatsApp kind of thing, and It's up on our St. John Astronomy Club page, usually on Raskin as well. But Kurt stated, early this week, stargazers have an opportunity to do an ISS marathon. Now, the International Space Station orbits the Earth at an altitude of about 400 kilometers, and at this height, it completes an orbit in about 90 minutes. The ISS has a large solar panels that reflect sunlight east or earthward, which make it bright enough to rival Jupiter and Venus at times. Usually, we can catch it once or twice in the morning twilight for a period of about 10 days, and then in the evening twilight for the same stretch. And then it is unseen for a while as the overhead passes are in daylight or in shadow. For a month either side of the summer solstice, when we have long periods of twilight, the ISS can be seen four or five times from evening through to morning. Now, if you see it in each pass throughout the night, you have completed the ISS marathon. I didn't know there was such a thing, but now I do. So you can see here, these are the three passes. This is tonight, I guess, or today. Two more tonight, 10 o'clock and 11:30. And then overnight, we've got another pass at 1:04 in the morning, and one again tomorrow night, and another one in the morning. So you can see these are all highlighted here. You can take a snapshot of that. And or you can go to heavensabove.com, which is where this information is captured from. So the brightness here, the lower the number, the brighter the object is. So minus 3.9, that's almost as bright as Venus. Venus might be around -4 now, Kurt, somewhere around there.
Around there, yeah.
So it's pretty close to the brightness of Venus right there. That's that one pass, and the rest of them are still around 2.2, 2.4, so they're still very bright. 2.7. If you go to that page, heavensabove.com, on the top right-hand corner, punch in your city, like in my case, St. John, and then click on ISS, and you can actually click on each one of these on the table, and it'll give you the spot across the sky, like the path across the sky that it's going to take. But it does tell you the start times here, the highest point, and the end times, and whether the pass is visible or not. So great stuff on that, Kurt. That's interesting. So let's see how many people can complete the ISS marathon this week. All we need is a few clear skies. Good luck with that. But yeah, that's kind of neat. So, okay, from there, I'm going to go on to just a few things that are coming up. The Monday, tomorrow night, the full flower moon, or the frog's croaking moon, I guess it's also called. The full moon actually arrives at 1:55 Atlantic time. Moonrise in the southeast tomorrow at 9:14 p.m. Atlantic time, and sunset in the west-northwest at 8:44 p.m. So just turn around and watch the sunset, and then half an hour later, while you're drinking your coffee, turn around and catch the moonrise in the southeast, which is kind of nice too. You should be able to get that from St. Charles Beach in the southeast tomorrow. And it's going to be fairly dark around 9:14 too, so we should have a lot of good contrast there. Another thing, tomorrow night too, Jupiter's great red spot is kind of dead center for us. Large enough to swallow the Earth. It is an anticyclone with winds of about 400 kilometers per hour, which has been continuously observed really since 1878. So see if you can catch that through a nice telescope. That gives you a nice view. All week long, we have Venus and Saturn in the east before sunrise. So looking to the east, you can be able to catch these two objects. Saturn a lot dimmer than Venus, but Venus, of course, stands right out really brightly. Later on in the month, we're going to have Saturn, Venus, and crescent moon. And I believe once Jupiter goes through solar conjunction, on superior conjunction, it'll be back up in the morning sky too. So that information all comes from places like this. This is from Lisa's Lookup, Astronomy and More. So you can find this chart at Lisa's page. She gives the event, the time, the date of the event, the peak time of the event, when's the best time to see it, and what you need for seeing tools, naked eye, binoculars, and telescope. You can find Lisa at Ruby Moonbeams on Instagram, Mastodon, Facebook, Threads, and now on Blue Sky. Thank you, Lisa. And of course, Kurt puts out this calendar for us. This is a May-June calendar, so this is the most updated one. This is for 6-week period, and here we are in this week coming up. So here's the events that we have coming up this week. Kurt lists all the events that are happening right up through that week. So here's the Venus, Moon, Saturn grouping coming up on next Friday, or 2 weeks from now, week from this Friday, in the morning sky. So you can find that calendar at sjastronomy.ca. You can download it right from there. And that's about all I get to say about that there.
Ta-da!
Here we go.
There you go. So send in your suggestion, folks, if you'd like to see some more segments. We used to do a whole kind of different segments, how-tos, and what are these, and how does this work, and how do you fix this, and all of that kind of stuff. So anything that you want to see like that, or if there's some segments that you used to really like and we haven't done in a while, send us in a suggestion and let us know what those are. And yeah, we'll kind of shake the tree up a little bit and see what falls on the ground.
I think we need to do that. A little bit of spicing up doesn't hurt any time at all. So.
Yeah.
All right. Well, that's our show then for this evening. We hope you enjoyed the program tonight. Special thanks goes out again to Kurt Nason for joining us tonight. Kurt, great topic. Thank you very much. Don't think I'm going to space anytime soon, but I'll prepare others for it for sure.
You live in space. What are you talking about?
I would for sure. Even that little dip, a little bleep, I'd even do that. Thanks goes out to Rosanna once again for another interesting Rosanna's Fun Fact. Thank you, Rosanna. Great topic. And a special thanks too goes out to all of you who share our program with your friends and family, Mark, Vicken, for sure, and Trudy as well, and all the rest of you. Remember too, we do love getting your photos, so send them in to astronomybythebay@gmail.com and we'll be happy to put them up on the next broadcast. So until next week, wishing you all clear skies. As we like to say, guys, open your eyes to view the skies and keep your scopes
Point it up.
Put it up. Good
Happy
night, everybody.
Mother's Day.
Have a great week. And how about we sign out on this page? Here we go.